So you need to know how to name your organic compounds, and there are, of course, these rules. We've got our prefixes, 1 up to 10 carbons you should know at least: met, et, prop, but, pent, hex, hept, oct, non, and deca, and the naming with the correct prefix or the correct suffix. You should know the rules. Please go through that first. And then, of course, you should be able to name compounds. We said the nomenclature. You should be able to draw them as well, and you should know that there are different types of chemical formulas. We can get molecular, structural, semi-structural, and condensed structural formula. And the main difference between these, fully structural would contain all the bonds and all the atoms within that chemical formula that are separately drawn out, while semi-structural just collapses all the substituted things onto one carbon, substituted elements onto one carbon, placing them together, and then with bonds to the next carbon, and then elements bonded to that, again grouped with it. So it's a condensed, it's a semi-structural, and condensed would simply just not have any bonds. Please take note that your substituted group always go in a bracket after the carbon it is attached to. And of course, there is an example that you can go through as well. So I would like to just quickly go through just typical long exam questions with you, and then we will sign off. So you will typically get maybe a grid or a table with all these organic compounds that you have to identify, and then from there we ask you any sort of reactions that can happen and occur with these as reactants, and if we add something else to them. So A through to J, and we need to name each of them. Please, let's quickly go through them. If we look at A, of course, what I would just like to do is just make sure, just bear with me, please. Make sure that we are in full screen mode. All right, so how do I name these compounds? You start numbering closest to the substituted group. Please go and circle your substituted groups. 2 iodines, a fluorine, and hydroxyl group. So this is obviously an alcohol. Where do you start numbering closest to the substituted group? So you start numbering on this carbon: 1, 2, 3, 4, 5, 6, and 7. So this would be heptanol. You must say where that ol is sitting. So this would be 1, 2, 3, 4. This would be heptanforol. And then, of course, you have to get your substituted groups in as well. And you also have to start with the lowest alphabetical number in those substituted groups. Please check that out. We will answer that now. In B, this is an alkyne, of course. And how many carbons? You start numbering here: 1, 2, 3, 4, 5. Do we stop there? No. The chain does not have to be straight, but just longest continuous chain: 1, 2, 3, 4, 5, and 6. So this is hexyne, and you must circle that as your substitute group, and then you can name it. Of course, this is an alkane, general homologous series, and this would just simply be an alkyne, which seems like ethyne. They use this in blowtorches. This has 2 carbons, and an alcohol. So this would be your typical drinking alcohol, which is forbidden at the moment, of course, because of the new measures of lockdown. But so this will be ethanol. This has 2 carbons, 5 hydrogens, and then a C over H. The substitute, the functional group is for a carboxylic acid. So this, of course, has 3 carbons, and it is propanoic acid. You can put E and F together to make what sort of compound? It's carboxylic acid and an alcohol. Of course, an ester and water would form from that. G is just a typical haloalkane, met, et, chloroethane, of course, and this is your dichloroethane. This is an alkene, ethene, and an ethane. And you need to now name compound A and B. Give the IUPAC name for C, containing 4 carbon atoms. Let's go and have a look at this. So the first one, we have mentioned that there's 2 iodines, a fluorine and a hydrogen. So this is an alcohol, and name for this fluoro 2,2 diiodo heptane 4-ol. Go check that out, please. For B, we said this is hexine, and 1, 2, 3, 4, 5, 6 hexine, so it's methyl hexine, but you need to get the numbering correct. So it's 4-methyl hex 2-ine. Please take note of that. There is no hyphen here. This methyl hex is one word. Please take note of that. So this should be simply one word. Right, please be careful there. And of course, if we have to give the IUPAC name for C, well, if they specify 4 carbons is found in that compound, of course, that would be butane, because it is the homologous series for an alkane with 4 carbons, butane. The question then asks, compound D is commonly used with oxygen in blowtorches to fuse metals at high temperatures. Name type of reaction, of course, any organic compound reacting with oxygen is combustion. So that's combustion.
Over the last few years, this demo has become a bit of a favourite, and it's certainly one that I can't help but love as well. All it really involves is some ethanol, which is just ordinary alcohol, which I've got here, and as you can see, it burns with this nice bluish yellow flame, but quite gently. And the reason it burns gently is that it actually has to turn into a gas before it will burn. It's not the liquid that's burning, so it can only burn as fast as the liquid evaporates. In the case of the bottle, I've sloshed the ethanol around, coating all the inside surfaces, allowing it to evaporate, and created this highly combustible mixture of ethanol, vapour and air, which is ready to burn. If we ignite it and slow down the footage, you can see that at first it burns with this really lovely clean blue flame, which is a sign of what's called complete combustion. This is where there's abundant oxygen to react with the fuel, so you just get the classic combustion products of carbon dioxide and water. As the reaction progresses, the oxygen starts to get consumed, and so as well as the carbon dioxide and water, you start to produce lots of tiny carbon particles which glow yellow with the heat of the flame. There's an interesting thing that you can see at the end of the reaction, which is this sort of yellow billowing flame, and that's probably because of fresh oxygen being drawn into the bottle through the nozzle and kind of mixing around with what's left of the fuel inside.
Write a balanced chemical reaction for this reaction and then state whether it's exothermic. Of course, when any exothermic reaction happens, an organic compound has to break its bonds to then react with oxygen. New bonds are formed. Energy is absorbed to break the bonds and released when the bonds are made. More energy is released than actually absorbed. So it's always an exothermic reaction. So let's write a balanced equation for that. Of course, we say this is combustion, it's an exothermic reaction. And this is what the balanced reaction is. 2 to 5 to 4 to 2. Please go check that out. You have ethine and oxygen forming 4 carbon dioxide and water molecules, 2 water molecules. You can use the fraction method with this, please, as well. And then from there, you can then take the fraction away by multiplying with the denominator.